So today's lesson is going to be on electrical and computer engineering. And so let's just do a quick round. So when I say electrical and computer engineering, what is the first thing you guys think of? You can put it in the chat or speak. Well, that's really cool. Computer building. That's really cool. My dad's an electrical engineer. And yeah, and so what both of you said is completely correct. Computer building and circuit boards are both important parts of electrical and computer engineering. And today we're going to learn what electrical and computer engineers do and what specifically they do. So there's some good thoughts. That's what I also think when it comes to electrical and computer engineering. And after doing more research, it is a lot like that. And I've also learned more stuff, so I hope you guys can learn some more stuff too. Okay, we can skip this. So today we're gonna talk about, so when I say ECE, that just means electrical and computer engineering. I just didn't want to type it out every single time or say every single time, so I just typed in ECE. So we're gonna go over an introduction, the fields specifically that you can go to, the coursework you have to take in college, and the skills of a future ECE, and the future of the field in general. So what is electrical and computer engineering? So ECEs use math and science to solve problems and create that's supposed to say solutions. They don't create problems, they create solutions to these problems. And as both of you said, you will work with computers and circuits and things like rapidly developing technology, such as AI and robotics, and you'll also use nano electronics and computers to develop products that solve real-life problems. So a lot of the technology in electrical and computer engineering is rapidly developing, like artificial intelligence and stuff, and you'll work with that to develop new solutions to problems. Oh, okay, anyways. So an electrical and computer engineer, not a chemical engineer, is a person that uses Yes, that is correct. Making circuit boards and making stuff, well, I guess you repeatedly test it to find potential questions. Yes, that's 100% correct. When testing and retesting, you obviously find and create new problems, and they find creative ways and unique ways to solve those problems. So you are 100% correct on that. And so electrical and computer engineers use physics and math, just like many other types of engineers. They have mastery in the concepts of electricity and electric circuits, board circuits, how you guys said, and they also work with programming and nano devices. So when you see like everyone just like, oh, I work in IT, or oh, I work in software engineering, that's the part of electrical and computer engineering that involves software and AI. So a typical ECE develops new machines, analyzes them, and controls the production of them. So these are just some main things that they do. They're very vague. They also analyze the machine testing results. They design material handling systems, which is the systems that basically handle like the AI and manage the AI and all those tech systems. And they also build robots such as AI again. Everything is really tied into artificial intelligence in this field. So if that's something if you're really intrigued and interested in artificial intelligence and working with rapidly developing technology, this may be a really good career for you. Okay, so some engineering fields that you could go into if you wanted to be in the ECE field are computer engineering, which as Anna said, is computer building. You can go into data systems, you can go into neuroengineering, so building building robots that maybe could perform surgery and stuff like that. You could go into working into communication networks like satellites and stuff like that. And you can work with nano devices, which is like atom-sized technology. You could also go into circuit engineering, which is related to circuit boards. So obviously, as we say before, to become a person in this field, you have to have a bachelor's degree in it, at least. And then you can go more. And if you want to go more into details into one of the fields, as we mentioned before, you can get a master's or potentially work up to a PhD in a specific field, so you can work in that much better. So as an ECE major in college, you'll be taking courses in software engineering, programming, robotics. You'll take obviously calculus and physics. I know you don't like calculus. You'll take computer systems. You'll learn a lot of electronic circuits, and you'll also study power systems. And so the typical electrical and computer engineer is good at developing schematics, is creative, interpersonal among people. They have very good problem solving skills, and they're good at applying physics theories. And that's why you have such a huge emphasis on physics and calculus, because you need to have that type of analytical thinking. Excuse me. So electrical engineering is definitely growing. It is 21.3% of all engineering degrees awarded. So as we know, as we can see from there, it's a very popular field. Its average starting salary is very high, with approximately $92,000. That's a very high starting salary. And there is a 2% job growth between 2018 and 2028. Sorry. Even though that may not seem high, tech is always growing. It's always fastly growing. So, yeah. So, next lesson will be a little bit longer. This one, since we didn't have a video, it wasn't that much longer. So if you have any questions, you can put them in the chat, or if you want to say anything. But that's all I have for you today. And your optional homework is to watch a course on crash course video on industrial engineering. So if anyone has any questions, can you talk about more about career opportunities? So when you say career opportunities, do you mean like fields that you can go into? Fields and companies. Okay, so I'm going to go back to the slide where I said related fields. Okay, so here's a slide on related engineering fields. So obviously, electrical engineering and computer engineering are two very diverse fields. There are a lot of career paths that you can take, as you can see on this slide. And obviously, tech is a field where you're gonna keep learning as you go. And because it's so fast developing, you're always gonna be learning on the go. So there's always that excitement of, oh, I'm learning this all the time, learning that all the time. So these are just some of the basic fields you can go into. There's definitely like way more. You can go way specific. The more specific you get in learning, the more you can do, because you have more knowledge. And regarding companies, a lot of companies are going to require some sort of tech. Like the government does a lot of research on AI and nano devices and stuff like that. And companies like Google, Facebook, Microsoft, Twitter, all those big tech companies also do a lot of research into artificial intelligence. And regarding neuroengineering, a lot of biomedical device-based companies are going to be going into that. Regarding circuit engineering and electromagnetics, there's going to be a lot of maybe like physics-based or maybe like product development-based companies that are going to look for people that are experienced in circuit engineering. Obviously, and one thing to keep in mind, there will always be a place for you in tech if you have the drive, the passion, and the knowledge. That's what I've learned from staying in a tech-heavy area. Like everyone here is tech, so I hope that helps. Okay, so I have a bright idea to stop short circuits. It popped into my head. What was your idea? I have a bright idea to stop short circuits. Funny. Yeah, what was the idea you were gonna talk about?
Okay, it's just gonna take too long to type, so I'm just gonna say it.
Okay.
So, like, if you take, like, a metal that melts around room temperature, like rubidium, and then you pass a wire through it, if it short circuits, it's gonna get hot, so it's just gonna melt the rubidium and just break the circuit.
Yeah,
So,
that's a good idea. Yeah,
the
in
thing
my
is, if
yeah.
rubidium sees water or oxygen or anything, it's just gonna explode.
Yeah, that's what happens. Yeah. Yeah, in my engineering class, when we were first experimenting with circuits and lights, I probably short circuited like 5 bulbs and they exploded. Luckily, not into my face because I had goggles on.
Oh, once I had two 9-volt batteries and someone put them in the way that short circuits both of them and basically ruined them because I wasn't at my desk and
uh,
then someone just did that. I don't know who. Everybody said no, they did not do that.
oh, sorry about that. That's okay. I get that. People just come out of nowhere and just change your stuff up. Oh yeah. So this is all I have for you guys. If you have anything else, you can always ask. Okay. And if you don't have anything else, you guys can go. Have a good Monday. Now it's like 5:30. It's nice outside here. I'm sure it's nice wherever you guys live. Okay. Hope you have some